Hi students, under algebra and number theory, we are into unit 2 which is finite fields and polynomials, and today's topic for discussion is division algorithm, so part 1. So I have two lectures for division algorithm, so this is part 1. So previously I had uploaded two lecture videos. First one was under polynomials and finding the degrees of the polynomials. Second one was roots of polynomial, and now we're moving on to the division algorithm, which is a very important part in your second unit. So now let's get into the outline of that particular PPT. Now we start with what is an introduction to the division algorithm. Second, the theorem, stating the theorem of division algorithm and problems. So let's get into the PPT. So first to start with the introduction. So division algorithm. Okay. So by the name, it may be new to you, but I'm going to relate a very similar word which you have used in your lower classes. HCF. Okay. You know what is HCF? Yeah, higher common factor. How do you find HCF? You keep dividing things, right? Same thing. Here also we are going to divide. So now, how was this HCF or this division algorithm came into existence? It was the work of Euclid, the great mathematician. Okay, an algorithm is a series of defined steps that gives a procedure for solving a type of problem. So here, an algorithm, this word is very familiar to you CSE and IT students. So where you say usually say algorithm, I had written an algorithm on this particular event or whatever it is. So algorithm, you know what is an algorithm? It is a well-defined steps, one by one after the other. First, you ask the variables input, then you do the manipulations, and then you give the output. Likewise, it's a step-by-step process. Now algebraic division, which can also be related to polynomial division, right, is very well known to us since our childhood, as I mentioned earlier. The concept of extending the polynomial division using modulo is done here. So usually in your lower classes you would have just divided a polynomial by the other polynomial. Here we are going to extend that particular result to a particular restrict over modulo. Right. So now in algebra, polynomial division is an algorithm for dividing a polynomial by another polynomial of the same or lower degree, a generalized version of the familiar arithmetic technique called long division. It can be done easily because it separates an otherwise very complex division problem into smaller ones. So now let's get into the next slide. So now I'm going to have the statement of division algorithm. So we'll declare f of x is not equal to 0 and g of x be polynomials in f of x. So what do you mean? You take two polynomials, f of x and g of x, right? Now why this f of x is not equal to 0 and g of x? They are not specified anything about g of x. Okay. Then their x is unique polynomials q of x and r of x belonging to f of x such that g of x is equal to q of x into f of x plus r of x. Is that clear? So this is highlighted in red so that you can easily remember, right? So what you are going to divide, this is called as your dividend. Remember, the dividend is equal to, what is this q of x? It's the quotient and into the function plus the remainder function, remainder polynomial, where r of x is equal to 0 or degree of r of x should be less than f of x. Very simple. Don't complicate with the such theorems. Just observe this particular right hand side. Okay. So what I'm going to do here is, for example, let me consider this 7. Right. This 7 is called as the dividend. I'm going to divide this 7 by 6 by 3. Sorry. If I'm going to divide this 7 over 3, what do I get? 3 twos are 6. My remainder is 1. So clearly I have mentioned this is my remainder This is the dividend. The one which is divided is dividend. The one which is dividing is the divisor. And the quotient. You know what is the quotient and what is the remainder? The dividend is the polynomial which is divided, and divisor is the polynomial which is dividing. So the remainder, how should you get your remainder? They clearly mentioned here. The remainder can either be 0. 0 is allowed, right? And necessarily the remainder should be less than the divisor. Is that clear? So if I'm going to divide this, going to be the divisor, which means 1. So I cannot divide this 1 by 3. So I'm just leaving that as my remainder. Even if it is 2, I can leave it. Suppose if it is 3, what do I do? Or what do? You divide that 3 over 3. Right? So again you write the quotient there and say 3 over 3 getting cancelled, and you're writing the answer as 0. So that's why you stop the process when the dividing process will be stopped. When the remainder is equal to 0 or the degree of the remainder is less than the degree of the divisor. So here f of x is the divisor, g of x is the function, q of x is the quotient, and r of x is the remainder. Is that clear? So that's why here it is mentioned that divisor, okay, should not be equal to 0. Suppose if I'm going to divide this g of x by this is equal to 0, what will be my answer? It will be undefined. So this is a division algorithm. The proof of division algorithm will be given in the later form of the lecture. So let's get into the problems. So first problem. For example, here it's a very simple example to start up with. So g of x is given as x cube minus 3x square plus 4x plus 5 by f of x is equal to x minus 2. So you know this division is performed in a very simple, elegant manner. So you write down the polynomial inside. The polynomial which has to be divided or dividend should be put up inside. The divisor should be outside. So it's going to be x cube minus 3x square plus 4x plus 5 divided over x minus 2. So how will I divide this? X cube divided by x. So what do I get? I'll be getting x cube by x. So which is x square. I'll write x square on top. Take this x square, multiply by this. So it's going to be x cube minus 2x square. Changing the sign, cancelling out. Again I'm getting the answer as minus x square. Dividing minus x square over x. I'll be getting minus x. So I'm writing it at the top in the quotient. So again multiplying that quotient here. So it will be minus x square plus 2x. My answer is 2x plus 5. Again 2x taken over and divided by x. I'll be getting 2. Put up 2 in that quotient. Take 2. Multiply it. It's going to be 2x minus 4. So the answer is change the sign. I'm getting it as 9. So the remainder is 9. So here the quotient is q of x is x square minus x plus 2, and the remainder is r of x is equal to 9. So how will I write it here? How did I write it here? Now this will be the dividend. The dividend will be equal to the product of the divisor and the quotient. This into this plus the remainder. So see here it is there clearly. This is the dividend. G of x is equal to the quotient into the function plus the remainder. So now the division can be extended to polynomials over finite fields. Now it's just a sample problem where you should understand how a polynomial is divided by the other polynomial. So like next we'll move on to the next problem. Okay, we'll continue with the second problem. So f of x is equal to 3x power 4 plus x cube plus 2x square plus 1, and g of x is x square plus 4x plus 2 in the modulo of 5. Find the quotient and the remainder when f of x is divided by g of x. So now the divisor is g of x and the dividend is f of x, and you're going to divide this dividend over the divisor, and you're going to jot down the remainder and the quotient. So first, you know what is z5, right? So how will I write these z5 elements? It starts from 0, 1, 2, 3, 4. It's a field. So the division. So if I'm going to divide this, so write down the polynomial f of x upon g of x. When I'm dividing this, right? So how do I divide? Take this first element 3x power 4, dividing that over x square. the answer will be 3x square. I put it in my numerator. Same process what we did in the previous problem. Take this 3x square and multiply to this entire set of equations. So it's going to be 3x power 4 plus 2x cube plus 6x square. Okay, so I'm going to multiply. So that here I'm saying 6x square, 6 is not here. I told you 12x cube, 12 is not here. So what has happened to the 12 and 6? So since 12 and 6 are numbers greater than 5, I got to perform the modulo division. Since 3 is less than modulo 5, I cannot divide. So what happened to 12? So 12, if I am going to divide this 12 over 5, it goes 2 times and the remainder is 2. If I am going to divide 6 over 5, my remainder is 1. So that remainder I will be writing it. You need not to write 12 and 6 here. Write on the reminders after the modulo division. Now, taking this term, right? So again, you're going to divide this 1 by 1. And again, you're going to find out, taking 4x and multiplying, it's going to be 4x cubed plus x square plus 3x, etc. So here it is going to be 4x square, it's going to be 16x square. So 16x square in the sense 16 is here. So 16 if I'm going to divide, so it's going to be 5 3s are 15, the remainder is 1. So that's why the remainder I've written as 1. So 4 2s are 8. 8 again dividing. So dividing 8, I'll be getting 1 time and the remainder is 3. So that's why the remainder is 3 here. The 4 is kept as such. So when I'm changing the sign, when I'm subtracting, I'm getting it as 2x plus 1. So that will be my the remainder. So now here the quotient is 3x square plus 4x and the remainder is 2x plus 1. So as per the division algorithm, I will be writing, what is this actually? This is your f of x. F of x is equal to divisor into the quotient plus the remainder. So this is the last problem for the discussion. So we have taken f of x as 3x square plus 4x plus 2 and g of x is 6x power 4 plus 4x cube plus 5x square plus 3x plus 1 are the polynomials in Z7. Okay, so we have to find the quotient and the remainder. So how will I write Z7? Z7 can be written as elements starting from 0 and stopping at 6. So you know how to do it. Put up the greater powered polynomial inside, treat that as your dividend and divide this by the divisor. Take the first element 6x power 4 dividing by 3x square. So dividing, it's going to be 2x square on the top. Put it on the quotient. Take 2x square and multiply this entire equation. It is going to be 6x power 4 plus 8x cube plus 4x square. So here 6 is less than 7. So need not to do touch up anything here. 8, right? 8 is definitely greater than 7. So taking that 8 dividing by 7, I'll be getting your answer as 1. That is a remainder as 1. So writing the remainder. Likewise, what do you do for the next number? You're getting 8. 2, sorry, you are getting it as 4. So 4 is less than 7. So no issues in that. So changing the sign and getting your answer. And 3x cube plus x square plus 3x. So 3x cube dividing by 3x square, I'm getting x. So multiply it. X into 3x square is 3x cube. X multiplied by 4x is 4x square plus x multiplied by 2 is 2x. Change the sign. Okay. Cancel out everything. And likewise, you just keep doing it step by step. And suppose if the number, what a coefficient of x, okay, suppose if the coefficient of x is greater than 7, you got to divide and write down the remainder of that particular coefficient. So the quotient is 2x square plus x plus 6 and the remainder is 5x plus 3. So here you will be writing your dividend is equal to divisor into quotient plus the remainder. Is that clear? So just small recap of what is a division algorithm is. So we are going to take two polynomials. One we treat as the divisor and the other we treat as the dividend. Necessarily the divisor should not be equal to 0. So after dividing, we can write the dividend as a product of the quotient and the divisor plus the remainder. This is what the division algorithm is. So after the division algorithm, we had extended the result to modulo division 2. That is, if the coefficient of x is greater than that particular modulo mentioned, then divide that particular coefficient and write down the remainder in that coefficient's place. Okay, I hope everything is cleared for you. What is the division algorithm and how do you divide a polynomial over another polynomial, and how do I find out the quotient, how do I find the modulo division, and write the things in a simplified manner. Thank you so much.